So here's the deal. A plane is located at point C on the diagram. So we have a plane up here in the ground. There are two towers located at point A and point B, and the distance between the towers is 1,600 feet. So that is not a red pen. So this distance here is 1,600 feet. And the angles of elevation are given in the diagram. So from tower A to the plane, that angle of elevation is 20, and from tower B, the angle of elevation is 33. It's closer to the plane, so it makes sense its elevation would be bigger, right? The angle of elevation. So we're asked to find distance BC. So here's the question. Okay, what's that distance? And there are two ways to go about a problem like this. One of them is what we did the other day. Okay, we had problems like this. We first wrote an equation for this big triangle. Okay, and I'm going to go ahead and do that, but then I'm going to actually do it a different way. I'm going to show you an easier way that'll save you time. So you don't have to write this down, but just take a look. So if I wanted to talk about this big outer triangle, and I'm trying to write something about that, do you agree, if I'm going to call this the height of the plane, we could say that tangent of my angle must be opposite over adjacent, where this distance here is what I am calling x. Okay? And then I could write a second equation. For the smaller triangle, now looking at this smaller one, tangent would be opposite over adjacent. Does that make sense? And then this is where it was kind of hard, right? We had a system of equations. We had to maybe solve them both for h, or solve this one for h and substitute it into the other, and it was kind of a hard problem to solve. Okay, but we could do it that way. An easier way is to learn how to deal with non-right triangles. And there are two formulas that help you do that. We're going to talk about one of them today. So one of them would be that if I don't want to look at these, I don't want to look at both triangles and have some system, because what I really want to do is just look at this one triangle. Okay? And I want to be able to just get the answer from there. So I know a couple things already. I know this angle, and I know the length of this side. And I know this is the one I'm supposed to find. Right? That's what I'm asked to find. Now that's all that's labeled, but I actually know more about this triangle than that. I know what? So how do I know angle B?
180 divided by...
Or not divided, but... Yeah, so whatever 180 minus 33 is, because these are supplementary angles, right? So it must be like 147, okay? Well, if I know those two, then I must know the third angle. So, because if you know two angles, you know all of them, right? Because they add up to 180. So, yeah, these add up to 67, so 13 degrees. So, we have all of our angles, 13 degrees, 20 degrees, 147. And here's what law of sines says. If I have a non-right triangle, in any triangle, and I'm going to write it in general terms, and then we'll come back to this. If I have any random triangle, it could be a right triangle, but it doesn't have to be. It works for any triangle at all. Let's say this is angle A, angle B, angle C, and this is side A then, this would be side B, this would be side C. So for any triangle, if you pick two sides and they're opposite angles, and we look at some fractions with those. So let's say if I want to talk about angle A and side A. if I was to take side A and divide it by the sine of its angle, okay? If I did that for any pair, they're always equal to each other. It would also be true that if I look at this pair, side B divided by the sine of its opposite angle, those are going to be equal to each other. They're equal fractions. It would also be true that looking at this angle and its side, taking side C and dividing it by the sine of angle C, those are going to be equal. Okay? Doesn't matter what pairs of angles and sides you look at, those fractions where the side divided by the sine of its opposite angle, that's going to be equal for any pairs in any triangle that you try to do that for. Okay? This is what's called law of sines. So I'm going to use this to do the problem, the airplane problem we just looked at. What's important about law of sines is that for the sides you know, you have to have the angle across from it. So I know that this side is 1,600 feet long. 13 degrees is the angle across from it, right? So I'm going to use those two to write a ratio. 1,600, I'm going to divide it by the sine of the angle that's across from it. Now I'm going to do that for a different pair. Now the other pair that I actually care about has to be the side I want to know, right? I want to know how big this side is. Okay, so if that's a side that I want to be able to solve for, and I'm going to go ahead and call it x. What's the angle across from side x? 20. It's the 20-degree angle. Okay, so those have to be used to write a ratio. So BC, which is what I'm solving for, that's what I'm calling my x. I'm going to divide that by the sine of the angle across from that side. And those are equal to each other. I have an equation that I can solve for x now. You don't have to do a whole system of equations. That right there will give you the answer. So how would I get x alone in something like this? Forget about what's on the left side of the equal sign for the moment. If x is being divided by something, you multiply it by that thing. Exactly. So I would multiply by the sine of 20 degrees. Because that way x is by itself, and this is what I actually type in my calculator. And that's it. Okay, so I have the sine of 20 degrees times 1,600, and it's divided by the sine of 13 degrees. And so BC is about 2,433-ish. So x is approximately 2,433 feet, approximately equal to. Does that make sense? So new formula, and you certainly could use right triangle trig like we've been doing, and it works out just fine. But this formula, as you can tell, now that you've already looked at some done the other way, this is way easier.